All right.
All right.
Okay, so far I like what you're doing. Okay. You didn't solve for x. This whole problem wants you to solve for x. Perhaps y. I can't see the beginning of the instructions here. But at a minimum, you have to solve for x. Okay. Now, how do you solve this? You can solve that for x.
So
Let's go back a step. First of all, go back to this step because you've made it harder by converting it to this. This is a quadratic. Learn to recognize when you're looking at a quadratic. If there's an x squared term, if there's an x term, and if there's a number, you're looking at a quadratic. How do you solve a quadratic?
put it into standard form.
Well, kinda, yeah. You move everything to one side and you let the other side be 0. So this is how I'm going to solve it, is by going from here to there. And I want the coefficient of the x squared term to be positive, so I move this negative x squared to the left.
Okay.
Now, how do I solve that?
So
Clue.
yeah. So so factor it.
Okay. Factors into what?
-1 and 3. So yeah, -1.
What are the answers? If this is true, what does x have to be? One of
negative over 1.
That's one thing that'll make that 0. One of these things has to be 0. You cannot multiply two entities together and get 0 unless one of them is 0. So what's the other possible x answer?
3. Or negative
3. Now, notice, I can't see what the instructions are here. What do they say?
Solve the following system both graphically and algebraically.
Okay. Graphically would be if I plotted both lines.
Yeah.
Okay, the one line might look like that. The other line's going to look like that. Notice that there are two solutions. Each one of them have an x and a y. So when x is equal to 1, what is the y value equal
to? 0.
Plug it into the simplest one you have. When x is equal to 1, what is y equal to? If y equals 2x minus 1.
Oh, so 1.
Plug it into that. Plug x into 1.
Yeah.
1 in for x.
So 2 times 1 is 2, minus 1 is 1.
Okay, my mistake. I apologize. And now when x is equal to minus 3, what is y equal to?
-7.
Yeah. So your two solutions whether you do it, we did it both ways, graphically and algebraically. Either one of them is going to give you this point and also this point down there, which is -3, -7. So those are actually your two solutions. You have an x and a y, two different places.
Okay.
Okay. The key about this problem is really when you get to this step right here, recognizing that you're looking at a quadratic, therefore you need to get everything on one side, 0 on the other, factor it, so forth and so on. Always with a quadratic. So you got to recognize that you're looking at a quadratic. All right. Now, do we want to go back to the first big idea? Do we want to go back to big ideas?
Yeah.
Okay. Let's see if I can get to it this time without the commercial. It's the first time I've ever gotten a commercial forced on me. Got it the moment I clicked on that. Huh? Not getting it this time. It's trying. That little thing over there is a commercial.
Okay, so
exit.
I know.
Yeah.
I know. Yeah, that works too.
Oh, report this ad?
Service brought the whole crew together.
What does that mean? That ad's not supposed to be there?
Only a Dignity Memorial provider can celebrate a life like no other.
Wow.
Find out how at life.
I was not able to close it out. That's pretty scary. Okay.
Yeah.
This memorial service brought the whole crew together.
Well, here. No, I can't even do it this way.
Dignity Memorial provider can celebrate a life.
It's going to knock down my volume with you. What page, Demetrius?
177.
Wow, that's almost like a bug.
Yeah.
That's okay. Thank God it goes away. No, it's trying to come back.
Oh, good. That's yeah.
No sound on that one at least. Which numbers?
Okay, so problem 6.
Okay.
So,
All right. Do you know how to do synthetic division?
Yeah.
Okay. You want to practice at doing synthetic? I see some other problems down here that require synthetic. So should we do this? We can do it both ways if you want. You can do this by long division or synthetic division.
We do the synthetic a little later on.
A little later on, okay. So shall we do it by long division?
Yeah.
Hold on. Now that I can turn my sound up, I need to in order to hear you. Okay. So if I'm doing this by long division, it's just like regular long division. Only you have to make sure you have, just like synthetic division, you have to have every power of x represented in both the dividend and the divisor.
Right.
In other words, if I didn't have a minus 14x, I'd have to put in plus 0x. Same thing with the divisor, x minus 5. If that was an x squared minus 5, I would need to divide by x squared plus 0x minus 5. Right? What's the first step? when doing this division?
So what multiplies to x?
Just do it as a division. You divide that term into that term. That's the first step, always. What's the answer?
3x.
Okay. Now, next step.
So it's 3x squared plus 15x.
Well, the next step is you take this 3x and you multiply it by both terms. In other words, the first step is I'm only dividing first term into first term. That's it. But then the second step is I'm multiplying my answer by both terms. So I get 3x squared minus 15x. And now, like all long division, you subtract. What do you get when you subtract?
Negative
That's
1x.
0. What do you get? What's minus 14x minus 15? Excuse me, minus a minus 15x.
It's 1x, or minus 1x.
Positive 1x. Go through it again. Minus 14 minus a minus 15. That is the same as minus 14 plus 15 equal to 1.
Okay. So then x minus 5 is the...
Right, and then you'll bring down the next term just like normal, and now it goes in there perfect one time. Plus 1. So that's your answer. Now, we can do that exact same problem by synthetic division if you want, or we can wait and do synthetic division. I see a whole bunch of other problems. Let's wait till we get to the other problems.
Okay. So the next set is 9 through 12.
All right. Now, this one, I don't know how to do this by synthetic division, but we should be able to do it by long division. As long as I don't run out of page. First step. In other words, the very first thing we do is check and make sure everything has every power of x. Already screwed it up. Did not have the power, did not have x to the 1 in the dividend. Okay, so first step.
So divide the x squared plus 2x minus 4. And
just take the first term. The first step is always to divide that into that. That's it. Forget about everything else. Just divide the first term. What do you get?
So 5x to the 4th. And then plus...
Now hold on. When I divide that term into that term, I get 5x squared. That's the end of the first step. With me?
Oh, yeah.
The second step is you take this single monomial term and you multiply it by everything, which always gives you 5x to the 4th there. In other words, this has to match that term. But now you continue to multiply it by all the other terms. So what's the rest of it?
5x squared times 2x, so that's 10x.
Give me a sign. Plus minus. Got to have a sign. You can't ignore the sign on these. It'll just get you in trouble. Subtract, what do you get?
Oh, wait, hold on. What? Wait. Oh, it's squared.
Oops, hold on, I didn't finish it, did I? I got to multiply that 5x squared by the minus 4. Minus 20x squared. Now subtract. Assume that's on your end, although my dogs are coming running.
Yeah, that's my dog.
I know. But both my dogs are now in my office.
All right. So
now subtract.
So 0 plus 8x to the third.
Hold on. We have minus 2 x to the third. That's immaterial. But we're subtracting a positive 10x cubed. What is that? You're not subtracting these. You need a minus sign right there.
Okay.
So what is minus 2 minus 10?
So that's minus 12x to the third.
Okay. Now do the subtraction on the next term.
Then that is plus 13x squared.
And now bring down that, even though it's 0, still bring it down. And now repeat.
Okay.
Next thing.
So it's just minus 12x.
Multiply.
So minus 12x to the third, plus, or minus 24x squared, plus 12 times 4 is 48x.
Now subtract.
All right, so 0.
That's always going to be 0, so I don't even bother doing that. I begin my subtraction right there.
So positive 37.
X squared.
Yeah, x squared. Minus 48x.
Minus 47x. Remember, it's 1x minus 48x. That's minus 47x.
It's a 0x. Not a 1.
Oh, my apologies. My apologies. Wow. You're right. When I brought it down, I wrote x, and that was a big mistake. Should have written that. Now, for sure, it's minus 48. Okay. And then what's the last step?
Then it's a 1 or 37.
Plus 37.
So that is 37. 37x squared plus, I don't know what 37 times.
74.
Yeah, 74.
Minus 148. Now, the numbers here aren't important. What is important is knowing what to do with this remainder. Now, when you do this last subtraction, you get minus 122x plus 109, I think.
Okay.
So, what is the answer? The answer is this with a remainder. And the remainder is minus 122x plus 109 divided by your divisor, which is x squared plus 2x minus 4. So your full answer is that. In other words, it did not divide evenly into that. It had a remainder. And the remainder is always whatever the remainder is divided by your divisor.
Okay.
Okay. What was that? That was number 9.
That was 9.
Yeah, what next?
10.
Okay. Set it up for me. What's my divisor?
So, x squared minus 3x minus 2 into 4x to the fourth plus 0 x to the third plus 0 x squared plus 5x minus 4.
Yeah. And those zeros are important. Don't make the mistake I made in the last one, which was leaving the 0 off there, because then we assume it's 1. And there's definitely a big difference between 0 and 1. So,
Right.
Okay. What next? I'll let you work me through the whole thing here. What goes first term in my quotient?
Okay. So, the first one is 4x squared, I think.
Yep.
All right. So multiply that. So that's 4x to the fourth minus 12x to the third minus.
Figure out your plus or minus first, your number second, and your variable third.
So then minus 4. 4 times 6, 8. 8x squared. So that gives you positive 12x to the third plus 8x squared. Right, and then plus 5x minus 4.
Actually, only bring down 1, just like long division. You only bring down the next term, and then you repeat.
Okay.
It's the next term in the quotient.
All right, so 12x, so positive 12x.
Rest of it.
So 12 negative 2, or yeah, 12x to the third minus 12 times 3 is 36 x squared minus 12 times 2 is 24x. So that gets you 44 x squared plus 29x.
Now you bring down the next term.
All right, so negative 4.
Okay, and one more time.
All right, so 44, positive 44.
Plus 44, okay.
Yeah.
Gives you
So
4x squared. Going. 3 times 44 is 132. What's the sign on it?
Positive.
We're doing positive 44 times minus 3x.
Yeah, negative.
142x minus 88. Subtract.
Oh, 88. 88. All right, so that gets you 161.
171x.
71. So yeah. And then a positive or plus 84.
Now, you know you're done at this point because you cannot divide x squared into x. So that's how I know I'm down to my remainder. Okay?
Right.
What's the full answer? In other words, what's their answer going to be on this?
4x squared plus 12x plus 44 plus 171x plus 84 over x squared minus 3x minus 2.
Yeah, and be careful if that's a minus sign. Really easy to get it wrong if you don't use parentheses properly. So far in all the problems we've had, that's been a plus sign. But like I said, be careful if it's subtraction. You have to make sure that it's being applied properly with parentheses and stuff. All right. What next? We on to synthetic division here?
Yeah.
Okay. Number 11. What goes in the box?
So hold on. Wait, what is it?
Opposite sign. It is the 0. The 0 here is 4.
Right, so 4.
That's what goes in the box, not minus 4, but the 0. In other words, if your factor was x minus 4 equals 0, then x equals 4. That's how you come up with it. Okay, what goes across the top?
1, 8, and then 1.
Okay, do one set for me. Make sure you can do them.
So you just bring that one down, so it's just 1. And then multiply 4 by 1, so that's 4. So you add them, so that gets you 12. Then multiply 4 by 12, so that's 48. And then so that's 49.
So what's the answer?
So
Here's the problem.
1x. Yeah, so 1x squared. Or, yeah, it's just x squared.
Hold on a second. Something wrong here. I cannot figure out what it is. Notice that you can't divide a quadratic by a linear term and get a quadratic. This got to be a linear term. But how come we have 3 numbers here?
Oh, is it just x plus 12 plus 49?
Remainder of 49.
Yeah.
X plus 12 with a remainder of 49 divided by x squared plus 8x plus 1. That's what's going on.
Um,
And in fact, you will learn, if you haven't already, that for x minus 4 to be a factor of that polynomial, you got to come up with a remainder of 0. It's called the zero remainder theorem. If
okay.
a polynomial is a factor of another polynomial, then when you divide the higher degree by the lower degree, you will get a remainder of 0 every single time. If you do not get a remainder of 0, then it is not a factor. And this is a good example. That's not x minus 4 is not a factor of that quadratic. When you do divide it, you get x plus 12 with this remainder that certainly is not 0.
Okay.
But this is the way you would express the answer. All right. I'm so used to dealing with them where the remainder is 0 and you take all the numbers you see and that's your answer. I forgot here that can't do that one on that one. Okay, so let's do 12. Now that you know how to do it, set me up on 12, everything.
So that the number in the box is 2. And so the numbers aside are 4, negative 13, and negative 5.
And again, if you're missing a variable, a power of a variable, you have to put in a 0. Just like with long division. You have to put in the dummy variables. Okay?
All right.
So that's 4.
So, yep. And then 4 times 2 is...
I know you know how to do it. I'll just speed things up here. What's our answer?
So 4x minus 5 minus 15 over I think it's 4x squared minus 13x minus 5.
Yeah. Now, so far, our numerators have always been numbers. I don't think it has to be. In other words, there's nothing that would prevent, well, maybe it does have to be now that I think about it. That's always going to only be a number. It's either going to be 0 or it's going to be some number. It's not going to ever be x. Interesting. How come we couldn't have a remainder of 15 plus x over that quadratic? I'm not sure. But anyway, so that was 12. Let's see if there's anything interesting. 13 is pretty much the same.
Okay.
Look at 23 just for a moment. We'll come back to these.
All right.
What did they do wrong on 23?
Oh, wait, we actually do 23.
Oh, good.
And that's actually in the next set, so.
Oh, okay.
Yeah. All right. I think we have enough time. So it's 15 through 25.
Okay. Well, as long as we're talking about 23, let's look at it for the moment.
Okay.
Because this is one of those where the person doing it made the mistake. We have to figure out what the mistake is.
Right.
Everything looks pretty normal. The problem here. That part is correct. When you divide a cubic by a linear term, you're going to get a quadratic. Excuse me, that part is not correct. That's the first thing you have to discover.
Oh, so the x In the original equation, it says x to the third. It's supposed to be x squared.
Well, no, that's not the mistake.
Oh.
In other words, you can certainly divide x to the third by x minus 2. But your answer is going to be a quadratic. So this has to be x squared. Oh, is that what you meant? Oh, yes, it is what you meant. Okay. Plus 2x to the 1 minus 1. And what do I do with this other one here?
It's 1 over the x.
That's the remainder. So here's what my answer is. Okay. And yeah, I guess the most important thing to learn here is that when you do this, their first term's always going to be squared. If I'm dividing x to the 5th by x, that first term's going to be x to the 4th. In other words, whatever you get when you subtract the exponents, that's what that term is. In this case, it's an x squared. All right, 15?
Yes.
Do it by synthetic.
So that is 3 that goes in the box. And then the numbers aside are 1 and 9. I think. No, 1, 0, and then 9.
You notice they do it a little differently over there. That's a little different.
Yeah.
Which one did they teach you in class?
The one that we're doing.
The way we're doing it?
Yeah.
Okay.
So 1 goes down, then that's 3, which gives you 3, and then 3 times 3 is 9, so that gives you 18.
So the answer is, which one are we doing? We're doing 14?
15.
15, excuse me.
That's it. So x plus 3 plus 18 over, what is it? X squared plus 9.
Actually, it's that.
X minus 3. Okay.
It's your divisor. In other words, it's the bottom. It's the denominator that goes there, not the dividend, which is the numerator. Okay?
All right.
Okay.
16.
Goes in the box.
1.
Goes across the top.
And just give me a second, I need to go grab a charger.
Just realize that there would be something useful to do here that I've never thought about doing, but I like it the more I think about it. But what goes across the top?
So, 3, and then -5. Oop, wait. Yeah, -5. And then 0, and then -2.
Now, it'd be useful if I knew that that was 3x cubed. So maybe in my head, I can do that. And what that tells me is that whatever number I bring down, that's going to be 3x squared. Always. In other words, I don't have to look back at the problem and realize that I'm dividing a cubic by a linear factor, which is what I would have to do. You notice that when we've done all this synthetic division and we get to our final answer, sometimes it's a little tricky figuring out what our exact final answer really is. In other words, here, let me finish this. other words, now we're staring at 4 numbers. Do we know whether we're looking at a cubic, a quadratic, a linear? It's hard to figure out.
Yeah.
But we know it's got to be 3x squared. Because I started out, that was cubed. So to me, it would actually be kind of helpful to put that power up there, knowing that whatever you get down here is going to be squared. Not that 3 isn't squared. And the 3 up here isn't cubed. Just means the x is cubed. And minus 2x minus 2. Keep on the right r for remainder. But it's minus 4 over what?
X minus 1.
And it might be useful to put that in parentheses.
All right.
Notice I could write that in a couple of ways. I could write it as 4 over 1 minus x. I could write it like that. Same thing. So by using parentheses, I don't know. I like to use parentheses there, even if they're not required. They don't really change your answer, but they do kind of clarify it. That's the remainder. Okay, 17?
Yep. So the number that goes in the box is 6. And then the numbers that go on the side are 1, -5, -8, 13, and -12.
I'll go ahead and do it. No, they're not going to give us one that results in that 0 remainder, are they?
No.
So what's my answer? Without looking at the original problem, can you tell?
It's a cubic or a quadratic or something like that.
Which problem are we doing? 17?
Yeah.
In other words, if I look at the original problem, then I know that this is a cubic. But without looking at the original problem, it's tough to tell. Because I don't know if I got a remainder of 0 still over here. But by looking at the original problem, I know it's a cubic, so it's got to be x cubed plus x squared minus 2x plus 1, with the remainder being that. But like I said, when that remainder ends up being 0, it can be a little confusing. I guess. I don't know. I guess if you see 5 numbers, you know it's a cubic.
Yeah.
The last number is 0, you still know it's a cubic. It's always 1 less than the numbers that you see there. I see 4 numbers, therefore the answer is a cubic. If I'd have seen 3 numbers, the answer would have been a quadratic. $18.
All right. So, let's see. -5. Ooh, it's a negative this time. -5. So the numbers are 1, 4, 16, and -35.
So I put the 0 in there?
Oh, I forgot about the 0.
Okay.
All right, so the one goes down, so it's just one.
That's okay. I know you know how to do this, so I'm just going to speed it up by doing it. The more important thing is, do you know what the answer is? You know what I'm saying?
Yeah.
So now tell me the answer.
So cubic.
So tell me.
Because
What's the answer?
cubic, I think.
What's the exact answer?
Oh, so x to the third minus x squared plus 5x minus 9 plus 10 over, what was the original? X plus 5.
Good. All right. What is 19? Scrolling down? No. Going back up to the right. What's this say? In 19 through 22, match the equivalent expression. Oh, I guess 19 through 22 end up matching A through D.
Okay.
Trying to figure out why they did it like this. No. In other words, we just did a ton of problems that were much harder than the ones they're showing us now. And yet now they give us multiple choice?
I guess. Yeah.
I mean, doesn't that seem a little strange to you also?
Yeah.
Well, there's really no way to determine without doing the exact steps we just did. So, I don't think. In other words, all of their answers have a divisor of x minus 2 in their remainder. So A through D could be correct, and the only way I know how to do it is to actually do the division. So
Right.
this is 1, 1 minus 3, 1, 2, 3, 6, 3. What's the answer for 19? Is it A, B, C, or D?
It is D
Okay.
for 19.
And they're all divided by 2. I'm just going to leave that 2 there.
Okay. All right, so then, yeah. 1, -1, -3.
Go ahead, I'll let you do it this time.
All right, so then that's, the one goes down, so then that's 2, so negative, or yeah, so 1 again, and then 2, so -1, so that's A.
Yeah.
C.
Yeah, pretty easy. Once you come up with that number, now it's easy to delineate which of these answers. You really don't need to know this part. All you need to know is the remainder for all 4 of these, huh?
Yeah.
In other words, all 4 remainders are different numbers. So once you come up with that remainder, you're kind of done. So that's
Yeah.
C, and that has to be B. Okay, what else after 22?
23, 24, 25.
Okay,
And then that's it.
okay. did 23. See what they did wrong on 24. They do wrong.
So, they didn't add the 0 in as a, or the 2 0?
Correct. There should be a 0 between the 1 and the -5.
Yep.
You need a dummy variable for the missing x squared. And 25.
Yep. And then that's the last one.
So what goes in the box and across the top?
All right. So the box. So that is -1.
Correct. In other words, the factor would be x plus 1 here. And they're not giving us the factor like they did in the previous problems. They're giving us the answer. X equal -1, so you put whatever x is equal to in the box.
Right.
Across the top.
Right. So -1, -8, and 30.
And I'll let you do this one since it's the last one.
So the -1 goes down. -1 times -1 is 1, so that is -7. Then -7 times -1 is 7, and so that's 37. So -x minus 7 plus 37 over x equals -1. I don't know.
X plus 1. In other words, if x equals -1, they got that because x plus 1 was equal to 0. In other words, that was the linear factor.
Okay.
If I had told you that it was divided by x plus 1, you'd have put -1 in the box, right? So if you put -1 in the box, it's the same as dividing it by x plus 1. So that's what goes down there.
Okay.
Here it would be x minus 3. Here it would be x minus 2. Here it would be x plus 4, x minus 6, and so forth.
Okay.
Okay? All right, Demetrius.
All right.
I will let you off a few minutes early here because I think you're in good shape on this stuff.
Yeah.
Seem like you know it pretty good.
Yeah.
All right.
All right.
Talk to you on Thursday. Bye-bye.
Yep. Bye.